Hey, Ian, how you going?
Good, thanks everyone. G'day. Welcome to 5054. Date's the 10th of May 2022, and tonight we're just going to go over some of the issues that have risen from our first project assignment, which is all to do with coordinate calculations and transformations. And I've started to record. And so let's just get set up here. So it may take a little while just to work through, but I won't be giving any answers, of course. It's up to you to work that out. But I'll just identify the software. Some of it's a little bit obscure, and happy to sort of point you in the right direction. And just bear with me. I'll just take it slow. All right. Task 1 requires us to convert between spheroidal coordinates in GDA 2020 and map grid coordinates in MGA 2020. And we're given some information. Spheroidal coordinates, ellipsoidal coordinates, of course. The two words are interchangeable. And we have, so step 1. So the two tasks, there's two main tasks in the assignment, and each task has a series of individual steps, and there's different software and different processes needed for each step. Okay, I'm going to ask you a question because I'm not telling you all the answers, of course. That wouldn't be right. Let's have a look at our notes. And we've got to convert between GDA 2020 and geographic and grid. Which software do we use for that? So it's part of what we covered in our notes, and we used it.
Our Excel?
The Excel sheet?
Well, definitely it's an Excel sheet. There's various Excel sheets, and
I think it might be the Kruger Lambda series Excel.
Yeah.
At least that's what I used. Except I had some issues with the last one where it asked the datum as AGD66.
So yeah, some of the data, it works pretty well for GDA 2020 and 94. Not so well for AGD 66. So let's see what we found. That. And I put some additional documents up on the Moodle for you to have a look at, and some of the documents related to this particular website that you can go to and get the appropriate find the appropriate tool. So the 7 little snips from the website, and they're all called AGD66 1, 2, 3, and 4. And let's share the first one on there. So this is just a what's the name shot snip of the website, and so that's number 1, number 2, number 3, number 4, and it actually has a online conversion for you to use. All right. So have a look at that. It does have some of these old map grids and datums that are no longer available. So you should be able to find a tool in that to solve that issue. Any questions? Number 3. Oh, sorry.
So yeah, does it want it wants the answer in MGA 2020, right? Like the output is MGA 2020, correct?
Yeah, so that Kruger series, you can have a look at that software. Now we use this.
Yep.
So it converts from geographic to grid, but within the same datum.
Okay, cool. And what does it mean by side?
SAD.
No, side. So on the Word document, like the assignment,
yep,
it asks for the ellipsoid and the side. Can you shed some light onto maybe both and what you're after in that?
Sure. Yep. So what it means is there's our central meridian, the dashed line.
Yep.
Which side of the central meridian is the point located? Is it the right-hand side or the left-hand side?
So just left or right will suffice?
Exactly.
Okay. And what about the ellipsoid?
Yep.
Is that
so
GRS 80? Is that like?
Well, I'm not going to tell you the answers. So
I know, but like, is that an ellipsoid that might?
Well, do your research.
Fair enough.
Yeah. It's in the notes. Just be wary, the third one there is not GRS 80. Okay, so step 2. You're given a whole heap of skims marks, and we've been asked to refer to the MGA 2020 skims report below, prepared calculations in the direction of the 2 marks noted involving arc chord, plane bearing, ellipsoidal distance, and plane distance. And it refers to us using the grid calc spreadsheet. You all have the grid calc spreadsheet available to you. And so they're in pairs, if you like, and in pairs. So there's 2, 4, 6, there's 8 skims marks. So you'd be calculating so the first one from PM 4874 to TS, which stands for trig station, TS 12241. So you take them in pairs and calculate from one to the other, because the direction's important. All those various items, and you enter them on page 9 of your assessment sheet, just from one across to the from the left right across to the right hand side.
Ian?
Yep.
For this one, the grid convergence you are asking for.
Yep.
Which point? Like the first one or the second one?
Well, it has to be the first one.
Okay. Yeah.
Okay, so that's that. Just page 10, it says show equation used to check plane difference distance calculation using combined scale factor between two marks. And then it says explain how level terrain distance is calculated in grid calc spreadsheet. Just requires a little bit of investigation to come up with an answer to that. The level terrain distance we've covered in our notes, and you have to sort of put in there a written response to that.
I've figured out an answer to this, but I couldn't find a lot of information about the combined scale factor. I thought that was applied to the ground distance, which is not something that we got or calculated in the grid calc. Am I wrong in that?
We've covered. Did you Google combined scale factor? Let's do that. See what
I did have a Google. I couldn't find much. You might.
Just gotta get the right spreadsheets. Versus.
I had a look through the GDA 2020 technical manual too, and it was pretty scarce on information on it, but I sort of put together what I gleaned from it.
Okay, you can come up with a bit of an answer from what I've just shown you there on that website, Spatial Services, which is the government surveyor's website. Level terrain distance we have covered, and just do a little bit more research on it, but it comes up in your notes here. Level terrain distance. Sorry, just do a little bit of research. You know, what is it? Where do you might find an explanation of that? Okay, and that's really all I'm going to talk about there. And then it goes on to say, describe where each PM exists within the zone. How does the grid convergence at point scale help you determine where each point is in relation to the central meridian? And it's given you various PMs. Now you have software that you use a lot that you can answer that question, the first part of the question. Describe where each PM exists within the zone. Now, those PMs are given to us, so we have their coordinates. Yeah. So let's go back to our zone. The central meridian of every zone has an easting of 500,000. Yep. That's number one. The distance from central meridian to the edge of the zone is 300,000 metres. I think I've got that right. So, grid convergence, have a think about that. It came up. Here. Find it. Keep missing it. Page 20 of our reference. So grid convergence, yeah? So grid convergence is this little angular quantity here between grid north and the meridian. So central meridian, that's a meridian, but the central meridian is just like a vertical line. because that's the one touching. But so the meridians on the right-hand side curve around to the top, and the meridians on the left-hand side of the central meridian curve from the bottom, from South Pole, if you like, sort of around in that way. So if true north is a tangent to the meridian, then the little angle, the grid convergence changes sign on one side of the central meridian to the other. And if we go and look at the definitions, have a look at the definitions there, you'll get a bit of a feel for how that can help you position it. So that's all I'll say on that. Okay, so moving on, step 3. Step 3, list the formula used to compute the following. And when it says list the formula, it doesn't mean write out the formula. It just means to make reference to the formula that is used, that is accepted and used to calculate that information. We downloaded it, but it's actually, the formula is actually in this manual. Yep. So just go and find that. We just need the name of it. Step 4. Calculate GDA 2020 geographic coordinates. And we're given various skims marks. Okay, that's it. 2, 6. No. You're given the latitude and longitude, which are for those 3. Let's just go and find what we've been given. Just I think that's an error on the questions. I think they're giving you the answers.
I thought we used
sorry, yes.
Vincenti's.
We did. Sorry. Yep, I was getting ahead of myself. Yeah, so you're given those latitude and longitudes and use them down below from 2. So you've got to use one of the formulas that we downloaded and used in class. So you've got to choose the appropriate formula.
Can't we just use an Excel? Is that what you mean?
Yes. Yeah, it's an Excel program to calculate those values. Some are inverse solutions, some are direct solutions. Okay, so it's pretty straightforward. Task number 2. So that finishes task number 1. Task number 2, transformation of coordinates. And the assignment uses some software that we haven't covered, but we can access. So let's go and find. So we're on step 1. It says use this geoid software to calculate 2D transform coordinates of the data specified. Refer to Google Earth to search the nearest town. And let's have a look at that. So let's see if we can find. I found geoid software, and I think I've given you some indication of where that might be. Geoid. So again, spatial services, and it can be downloaded. Let's go and find that website. Let's find it. And gives us some direction on downloading the software. And there is some reference to some grid files. And we'll need certainly some of those to do some of your calculations. These grid files are the GSB files that the question refers to. So if we download it, which I have, and then I've installed it. So that's what it looks like, and I'm going to open it in a sec. But one of the things you've got to do is also get the data. And there's this, the A66 national set of data, which is, you can download from that website. But there's some other sets of data as well that you'll need. Certainly this national 84 set of data. If you Google that, you should be able to find it. You'll need that for some of the conversions. And so we just jump back and run it. It's a little DOSy sort of program. We want to do the high accuracy transformations. Option 1, high accuracy method. Yeah, they're the ones we're after.
Sorry, where do we get this data from?
What?
This data you're talking about to use the program. You said we needed something to use this program.
Had to download it.
Is that it?
Yeah, there's some national files. Step 1, step 2, use high accuracy transformations. You will need to use the national grid file covering your state or area. Yep. And then it says the file needs to be copied into a folder called data. established in the directory where you placed a Judo program. So you will need that one, national grid file. There's another one as well, which I'll just refer to. Find. The A66 national file is the one you'll get from there. There's another file, national 84 file, which you can download, and I'll show you where to download it from the ICSM Git store. We'll see where that is. So, and that's where I've downloaded these other ones as well. So just go back. Software. Yeah, it's pretty DOSy, sort of clunky, but look, it works okay. So we just click OK. We go and get the GSB file. And data. Yep, and that's what they look like. And so the national one, open that. It populates it. Yep, it's okay. And then you get something that looks like this. So GDA 94, it's a GDA 94. Here we go. You can enter the values in there. Now the numbers are entered as 32 full stop 23 51.31258, and you just click out here. You can see, just make sure it's entered in the correct number. Yeah, it took me a little bit of fiddling just to get the right format. And then you enter in that one, and you just make sure this one's set. So it's from to, so this one's set to AMG. Yep, AMG. And you'll set the zone. You're given the, no, you haven't set the zone, so that's all right. So zone is nowhere to be found. That's okay, because we're entering in Latin long. That's fine. Then it'll calculate the zone for us. Calculate, bang. Yep. So we're now converting GDA 94, yep, to AMG 66. Yep, and that's the easting, northing, and the zones there. And then it says, give me the town and the GSB file. The GSB file is just that, a 66 national file. Yep. The town, the question asks you to use Google Earth. Google Earth will take latitudes and longitudes just as part of a search option up the top. Rather than putting an address or a town, you can enter latitudes south, longitudes east. Yep. If you Google it, you'll work out how to do it. It's pretty straightforward, right? And then it'll zoom in on a spot, zoom out, and there's typically a town there, town like Alice. Yep. And you just write that in.
Sorry, I've got a good question. We've done some calculations on that question, and I don't know whether or not it's worth mentioning that it may be a negative, or is it positive? Because every time I put a positive, it takes me out to the middle of the sea.
Well, you're doing something wrong.
Okay, maybe I wasn't able to use that program before, so hopefully I get.
Yeah, so you had to have that GSB file.
Okay, cool.
So there's GDA 94, 94, AMG 84. The 84s, you need a separate file, and it's this one. So the national file is used for most everything, but where you're using a datum that's got 84 in it, you'll need this one. And we can get that from the ICSM GitHub Transformation Grid repository. Yep. We've used this before. And there's that national 84 GSB file. Yep. There's the A66 national file. So you need that and that. You may need these other ones as well. They're really big files.
Ian, at the start, at the start of the Geoid program, when you just ran through it, and it wants you to select your GSB file.
Yep.
I've downloaded those, but when I click that drop down, it's still saying I've got no GSB files. Am I?
Well, did you?
Sorry, Ian.
So it's got one.
I think you're meant to save them in a folder called data so it can read to it, like how Ian has it.
Yeah, we'll do that. Thank you.
The notes actually, or not the notes, the website tells you that.
Oh, yeah.
So here it says here. So step 1 is downloaded. Step 2, you've got to follow that. Okay.
Yep. Thanks.
Okay. Moving on. And oh yeah. G'day. The two main installation files are here. There's a 64-bit file, is that one, or a 32-bit file, which is that one you can't download from this particular point, but they're the two files you're interested in. And then if we go up to the binaries, yeah, check it out. There they are there. So just got to pick the one that suits your computer. And just be aware where that gets saved, like the exe file. And there it is. So these transformation grids are the GSB files. You've got to choose the right ones. And so, okay, so we're on step 2, task 2, step 2, and we're using the G-Day software. It can be downloaded from the ICSM website. Use G-Day software with the relevant GSB file to compute 2D coordinate transformations. So would you like to choose one? Yes, please. Browse. GSB file. So natural one is used for most. So it's picked it up and it's brought in the parameters for the file. Transformation parameters 94 to 2020. Let's see if that works for us. I think so. Can't remember. Okay. All right. So what do we want? Output coordinates. We don't want that. We're trying to go from just, yeah, we don't want that. Don't want that. Don't want that. Just bear with me and set that up again. because Ian's using the wrong software. Do we do that one? Step 2, beg your pardon. Step 2.
Sorry, Ian.
Yep.
Which GSB file was used for GDA? Is it National 84? Or A66?
It depends on the on your datum. Yep.
Okay. What are the GSB files?
GSB stands for weird sort of file. Golden software boundary. Apparently that can be converted to an ASCII format. I think they're used in geographic information systems more than anything.
Okay. So what's the difference between VA66 and 84? Is that?
Well, remember the historical.
Is that like AGD 66? And
so we're at the moment today we're on GDA 2020, yeah.
Yes.
But you see, there's all these previous ones, and so coordinates or old marks, trig stations, all sorts of things. They would have had to use them to convert, old data into newer data, and so I guess in a way they're just sort of still hanging around. I imagine like all the points that we would ever use are now in GDA 2020, but this particular assessment goes back to these historical datums and then uses coordinates in those and uses techniques to transform them into more modern day coordinates.
What about 94 to 2020? Do we have a grid that's 94 or do we use one of the other ones?
Just ask me again.
Sorry, so we've got the 66 grid, we've got the 84 grid, but what about like if we're transforming from 94, GDA 94 to 2020? Because that's what step 2 is, using the GDA datum transformations. It's 94 to 2020. So what grid would we use there? GSB, sorry.
Pretty sure the national one picks up the GDA 94 to 2020.
Okay, cool.
I think that's the case. Sorry, we're on step 2. So GDA. Step 2. Okay, GDA convert. I had this working. Now it's not working for me. It's not really what systems. GDA, OMGA. GDA. Let's go back to our notes. Transformations.
Sorry, Ian, when you got a moment.
GDA. Okay, so yep. So I'll find the software asset. Yep.
I did this question a little bit different. I used the spatial services 7-parameter transformation method. That gave me MGA 94 coordinates. And then I just used, there's a MGA 94 to MGA 2020 converter.
Yep, sounds good. I thought I made some notes here.
But I'm now using the G'day software, I'm getting different answers.
I think there is a 94 2020 GSB. I'm looking at the files on GitHub, and there's a 94 2020 conformal GSB and 94 2020 conformal and distortion GSB. Would that be what we'd use for this question, Ian, or still just the national?
No, I think it's the conformal and distortion ones. So it's either those that are going to work for us. Pretty sure. Just sorry, I'm just. So it does say use G'day. Settings. Include. Okay, so research. Yep. And yeah, I thought I had it working yesterday, and so downloaded that, use that. Yeah. Yeah, I'll just try a couple of other things. I had it working, and I just lost it. I think I've got it now. Okay. So, yeah, so not getting the answer I was after. Got it to work up to a point, so I'll have to go back to the just clarify that process for you. So I've downloaded these additional GSB files as a conformal one and a conformal and distortion one. And they come off that ICSM website. And there they are there. These are the ICSM. This is this GitHub, which contains all the download. So this, you pick up this terminology from our notes and from the technical reference that we've been using. And so these are being created to assist in the conversion of coordinates in one form to other coordinates. So that was step 2. So I've got to come back to you and just clarify that because something's going wrong there for me. And we'll go on to step 3. Okay.
So Ian, how did you go about getting the answers for that? You said you thought you had it set up.
Yeah, I'll have to come back to you on that. So I'm
Right.
using the GDay software. So that question in step 2, should he use that software?
Yep.
Yep. So under tools, you can set the input and output formats.
Yep.
But it'll just come out with an error, and it wasn't, even when I was running it, it didn't give me the answers I was looking for.
Would it be too much to ask that you nudge us in the right direction and at least give us the right GSB to use for that one?
Yeah, so that's what I said to you, Cameron, that I'll have to come back to you, mate.
Okay. Yeah, hell yeah. Sounds good.
So step 3, let's go and find our file, and it does give us a reference to ga.gov.au. GA stands for Geoscience Australia. And what we're after are these tools. And excuse me, so I'll go back and we'll come back in, show you how to get there. So Geoscience Australia, federal government organisation, does thousands of different things. It's really quite amazing organisation. And one of the little one of the projects it runs is all to do with the geodesy. So being a federal government body, it's interested in data on across the continent. So I'm going to type in there, just come to its home page, and geodetic calculators. Geodetic calculation methods. And and it says use the Kruger N series to perform zone-to-zone transformations. So just, excuse me, it says provide. So it's a two-step process. You're given coordinates. These are all in MGA 2020. The given coordinates there, you're going to convert those to geographic coordinates on GDA 2020. And then lastly, convert those to a different zone. And you wonder how on earth can that be possible? Geographic coordinates, of course, are fixed, they're Earth-centered. And then, you know, if you project those coordinates down on the grid, that particular point appears in a particular zone somewhere on the Earth's surface.
So we just need to get it so that it's the coordinates that you would use if you were putting it into a different grid. Yep, all good.
Well, hang on, let me finish. So there's a point on the Earth's surface, so projects down into a zone, yep, on the grid. Now, it can only really have one position, but because it's right near the zone boundary, there's actually a overlap, and we can calculate its coordinates based on a different zone. So it relates to points that are near the zone boundaries, either left or right. So imagine that's why I've chosen these points, that I can look at the easting values and get some feel for where they are. Okay, so firstly, let's go and find the software. So we got grid to let's put in some data and see what happens. And so it's converted it to a latitude, and these are decimal degrees, longitude, decimal degrees, a grid convergence, and a point scale factor. And there's our projection ellipsoid. We just use that, then the geographic to grid, but change the zone, and it'll calculate the transform coordinates for us. So we can just do that all on that Geoscience Australia website. It does go on to ask point scale, which are given there, grid convergence you're given. Yep. And then it also says describe where each PM exists within the zone. So knowing that the central meridian has an easting of 500, you can make an estimate of where, and I want you to research the width of the zone. I think I mentioned it before, but if we know the width of the zone and the easting of the central meridian, then you can work out the easting of the edges of the zones left and right, and that will help you answer that question. How does grid convergence and point scale help you determine? This is repeated from an earlier question. Identify the point where it is not practical to perform zone-to-zone transformations. Identify the point where it is impractical. It is not practical to perform zone-to-zone transformations. Remember what I said, it's only where points are close to the zone boundary, far left or far right, where we're allowed a, it's a 1/2 degree overlap, that you're able to calculate for the same point coordinates in one zone and coordinates in a different zone. There'll be different coordinates. But once it's outside that, you can't do it. So one of those points is definitely outside it. Turn over the page, step 4. I'll put a query through to the designer of the assessment. The question says, for this step, use Geoscience Australia transformations, so transformation conversion. So GA, geodetic calculations, this is the same website we're on now. And just go back. And don't want to go there. But it's all right, it comes back to the right spot. Transformation conversions, GDA 94 to GDA 2020, and sort of telling us this is sort of the right thing. Now it says you must conduct a 7-parameter similarity transformation from GDA 94 to GDA 2020 for that mark. Yep. So you're given some that would probably be MGA 94 coordinates, and you've got to convert them to GDA 2020. You're also given some additional heights. That's the sort of the information that you might find on a SCIMS search. And then you give various steps and you're required to write an answer. Now the answers, there's some basic calculations, but that's all. A lot of it's descriptive. And so it says provide 7-parameter, provide the 7 parameters used to convert between GDA. These are published in the GDA 20 technical manual. These are published. So you've got to go and find them. Yeah. I don't know where they are. Well, I know where they are. So you've got to go to that manual and find the 7 parameters that are used, and you can use your snipping tool and paste it in that spot. Yep. And identify the spheroid used for GDA and blah, 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 blah. You know, that's in your notes. It's in the notes I've given you as well. Compute geodetic coordinates and GRS geocentric Cartesian coordinates in GD94. Sorry. B, compute the ellipsoidal height. We've gone through that in class. You're given a geoid and an HD level. You should go calculate the ellipsoidal height. C, compute the geodetic coordinates and the geocentric Cartesian coordinates. You've got the software to do that. Compute GRS geocentric Cartesian coordinates in GDA 2020. You've got the software to do that. Calculate geodetic coordinates in Yep. So these are the steps in the process, I guess. Calculate MJ coordinates. So you've got the software that does this. Check your results. Okay. You've got you've definitely got the software to do all this. Okay. Compare ellipsoidal heights. So, compare means compare. Find out what they are and write them on there. And then you can deduce the difference from it. All right, as far as I'm going to go. I think we've added some additional information there. I've got to come back to you on that, that odd software GDay. Couldn't quite get it to work for me. Thought I had, but I didn't. So I think that was step 2.
Step 2. Just on that, Ian, it also asks for the projection. Is that the central meridian?
No.
No.
Wouldn't that be just universal transverse Mercator?
No.
Okay.
What is? Sorry, I'll let you finish.
Six. Just got to find out technical manual. Right, okay, sorry. Technical manual. Oh, yeah. So it was important because it, it had a history. So geodetic coordinates have been around for a long time. Earth-based, not necessarily Earth-centered originally, but certainly lately, in the past, since 94, they've been geocentric, and that helped us with GNSS. But there has been lots of different coordinates, so it's been important to be able to transform from old coordinate systems into new systems. Yep. So projection process that some of you raised was having a Earth-centered or a ellipsoidal coordinate system of latitude, longitude, and ellipsoidal height, or Cartesian coordinates, which are X, Y, and Z. Both are centered. They're both centered, but and one can be transformed from another using some of the software that I've given you. But that's just on the Earth's surface. Yeah, that's just got an issue with my VPN software. So just hang on a sec. We'll be finishing close to 8 o'clock. That are Earth-centered and either latitude, longitude, ellipsoidal height, or X, Y, Z. Just having some issues with my software. I hope it still picks up what I'm saying. And then, of course, apart from that, so these are our reference frames. And then we do our projection. So we project these 3D Earth-centered coordinates down onto a flat plane, and that is a mathematical process. And all these, so these coordinate transformations are all based on these Earth-centered to Earth-centered, but these ones weren't Earth-centered, converting them to Earth-centered coordinates. So these are still latitude, longitude coordinates. Here's grid coordinates down here, map grid of Australia down here. So there's just different complex, very complex mathematical transformations that occur on some coordinates to convert them into different sorts of coordinates. We don't need to be too complex about this.
Right, so more or less we're just saying, is it Earth-centered or a grid coordinate?
Yeah, but all the transformations, so these transformation grids, which are those basically those GSP files, are national transformation versions of binary grid shift, there it is, format, and are the preferred method for transforming between Australian datums. Datums, yeah, datums are not grid coordinates. They're the mathematical model of the geographic coordinates. Yep. So converting those down to, but they might be in some old format, and that's what I'm saying. I guess that, yeah, those that we understand that pretty well, but some of these other ones are pretty old. These 66 and 84, so it just gets more complex with coming up with a transformation file that does that. Okay. So there's two types. We did talk about this briefly. A conformal transformation grid. Remember the reason why we went to 2020, because the plate actually is moving. And so these transformation grids, one's conformal and distortion. And so this one predominantly just moves the plate, and then the Australian plate, and then this other one takes into account the regional distortion. So this one would be more accurate. Yeah. Just jump back into files. You can see there I was able to actually download the conformal and distortion GSB files from that that GitHub. Yep. So they're pretty big files. Big files. Took all ages to download. So I think they're the ones that are used in one of the questions that we were having problems with. Just got to go back and just to make sure that works. Couldn't get it to work. All right, I think that answers the question, gives you a pretty good idea. I think we've covered pretty well all the sources of any software that you'll need to complete it. It is due next week. I'm happy to accept it the following week. But we will be moving on. So like lectures as normal. I'm happy to answer any, odd queries on your project work. We will be moving into our next project, which is more Travis based, calculating arc chord and plane coordinates and things like that. So I'll be introducing that probably next week. This is week 13, and so it gives us about 5 weeks. I think there is a knowledge test as well. I think I'll have to double check that. Yes, there is. And we'll do that right at the end of semester. Having done the projects, it would have improved our knowledge, improved our overall knowledge of geodetic computations. Any questions before we knock off?
I'm still kind
all good.
of confused with that projection on question step 2, the G'day. I feel like you it wasn't quite the answer I was thinking you were gonna say, Ian.
Cameron.
Can you give me an example?
Cameron.
Like, yes.
Cameron, that's the one I said I'd come back to you, with a solution. Remember, I was trying to get it to work and I couldn't get the software to work.
Does G'day spit out the projection to write in that answer? Like,
does it spit it out? You've got to select it and use the appropriate projection.
Right. So instead of projection, maybe it should be GSB. Like, what file did grid? Yeah.
Yeah. Well, that's not me putting that on, but yes, you could be right.
Okay, because I think it's a bit vague on what it wants there. Projection. Okay, thanks for that, Ian.
Thank you. Okay, everyone.
I've got one question just for formality, particularly in task 2, step 2. There's a bunch of input values that aren't specified as any type of see, if you look at task 2, step 2, 3, the inputs, they're not in eastings, they're just numbers. Not eastings, not northings, not given as meters. So are we supposed to just assume that those are eastings, northings? And,
yes.
Where stated otherwise, units are in meters?
Of course, they're always in meters. So number 3, it says cause mark, MGA 2020. MGA 2020, they're grid coordinates, yeah? So typically easting, northing, and zone 56. So yes, it doesn't have E and N. Not sure why it doesn't, but it's got 306349.783. That would be an easting, and the other one would be a northing. Yeah. So
I just wanted to make sure that I raised that because like I could do it assuming that, and then they could have thrown us a curveball and put them in feet and inches. I mean,
I don't know what you're
some
talking
weird.
about.
They could have done some weird shit with the answers. I don't know.
That would. I don't know where that's come from. So thanks, Sam. Thanks, everyone.
I just want to be clear about everything.
It won't be saying any feet and inches, right? This is all in meters.
Yep. Right. Thanks.
Yep. Thanks, everyone.
Cheers.
Thank you, Ian.
Thank you, Ian.
Thank you.